Exploring TRAPPIST-1e in search of a habitable world. Since the discovery of the first exoplanets, the search for habitable worlds outside our solar system has been one of the main goals of modern astronomy. Among the numerous exoplanets discovered, TRAPPIST-1e has emerged as one of the most fascinating and promising candidates to host life beyond Earth. Located in the habitable zone of its host star, the TRAPPIST-1 system has captivated the scientific community and the general public. In this text, we will explore in detail the exoplanet TRAPPIST-1e, its characteristics, atmospheric conditions, possibility of hosting liquid water, and ongoing efforts to better understand this distant world. Discovery and basic characteristics. TRAPPIST-1e was discovered in February 2017, along with 6 other exoplanets orbiting the ultra-cool dwarf star TRAPPIST-1, located about 39 light-years away from Earth in the constellation of Aquarius. The TRAPPIST-1 system stands out for having 7 planets roughly the size of Earth, all orbiting very close to their parent star. TRAPPIST-1e is the 4th planet from the star, with an orbit that takes about 6 Earth days to complete. Its mass and size are similar to Earth's, making it a particularly interesting target for habitability-related studies. Atmospheric conditions and surface. The proximity of TRAPPIST-1e to its star results in unique and extreme atmospheric conditions. Its atmosphere can be heavily influenced by intense stellar radiation, leading to effects like violent winds and significant chemical changes. Studies based on atmospheric models suggest the presence of a dense atmosphere rich in gases like carbon dioxide and water vapor, but direct observations are still limited. TRAPPIST-1e's surface is an intriguing terrain, with possible geological features such as mountains, valleys, and plains. The estimated average temperature falls within the range of life-supporting temperatures, but varies considerably depending on location and atmospheric conditions. Possibility of liquid water and habitability. The presence of liquid water is one of the key indicators of habitability on exoplanets. On TRAPPIST-1e, the proximity to its star could result in liquid water on the surface, especially in areas shielded from temperature extremes and radiation. Theoretical models and simulations suggest that equatorial regions or mid-latitudes may have suitable conditions for the existence of liquid water, making TRAPPIST-1e a strong candidate for a habitable world. However, the precise surface conditions and the actual presence of liquid water are still subjects of study and debate among scientists. Future observations with advanced technologies, such as the James Webb Space Telescope, may offer valuable insights into the atmospheric composition and surface characteristics of TRAPPIST-1e. Challenges of life on TRAPPIST-1e. Although TRAPPIST-1e is a promising exoplanet in terms of habitability, it also faces significant challenges for life as we know it. Its proximity to the star may result in extreme conditions such as intense ultraviolet radiation and stellar flares, which could negatively impact the viability of exposed life on the surface. Additionally, atmospheric dynamics and interactions between the atmosphere, surface, and stellar radiation are complex and not yet fully understood. These factors present additional challenges in determining the actual habitability of TRAPPIST-1e and the possibility of complex life forms developing there. Observational efforts and future studies. Efforts to understand TRAPPIST-1e and the TRAPPIST-1 system are ongoing. Telescope observations, spectroscopic studies, and computational simulations continue to provide valuable data on atmospheric composition, geological structure, and potential habitability conditions of the planet. The launch of the James Webb Space Telescope represents a crucial milestone in the investigation of exoplanets like TRAPPIST-1e. With its advanced spectral analysis capability, the JWST will enable detailed analyses of TRAPPIST-1e's atmosphere and the detection of possible biomarkers, if they exist. 1E is one of the most intriguing exoplanets discovered to date. Its position in the habitable zone of its host star, coupled with its size similar to Earth's, has sparked significant interest among astronomers and astrobiologists. In this text, we will delve into actual studies related to TRAPPIST-1e, exploring its physical characteristics, atmospheric composition, possibility of liquid water, habitability, and the technological advances that are enabling a deeper understanding of this fascinating exoplanet. Discovery and context. TRAPPIST-1e is part of the TRAPPIST-1 star system, discovered in 2016 by the TRAPPIST-South telescope located at the La Silla Observatory in Chile. The central star, TRAPPIST-1, is an ultra-cool dwarf of spectral type M, located approximately 39 light-years from Earth in the Aquarius constellation. In February 2017, NASA's Spitzer Space Telescope confirmed the existence of 7 planets in the TRAPPIST-1 system, including the intriguing TRAPPIST-1 physical characteristics and orbit. TRAPPIST-1e is the 4th planet from TRAPPIST-1, with an orbit that takes about 6 Earth days to complete. Its mass and radius are approximately similar to Earth's, suggesting a rocky composition. Studies based on planetary transits and radial velocity measurements have provided crucial information about TRAPPIST-1e's mass, size, and density, contributing to our understanding of its internal structure. Atmospheric composition and spectroscopic studies. TRAPPIST-1e's atmospheric composition is a topic of great interest. Spectroscopic observations conducted by ground-based and space telescopes, such as the Hubble Space Telescope, have sought to identify the constituents of its atmosphere. Theoretical models suggest the presence of gases like carbon dioxide, methane, and water vapor, but direct detection of these elements is still challenging due to TRAPPIST-1e's relatively small size and intense stellar radiation that can mask atmospheric signatures. Possibility of liquid water and habitability. TRAPPIST-1e's location in the habitable zone of TRAPPIST-1 raises the crucial question of the existence of liquid water on its surface. Climate models and computational simulations have suggested that, despite the proximity to the star, TRAPPIST-1e could harbor liquid water on its surface, especially in regions shielded by favorable atmospheric conditions. Studies on ocean stability and temperature distribution are essential to assess the potential habitability of this exoplanet. Habitability studies and biomarkers. The search for biomarkers on exoplanets like TRAPPIST-1e is a rapidly growing area of research. Biomarkers are chemical or physical signals that may indicate the presence of life, such as oxygen in the atmosphere, methane in chemical equilibrium, and spectral features associated with biological activity. The James Webb Space Telescope, set to be launched soon, promises significant advances in detecting and analyzing biomarkers on exoplanets, including TRAPPIST-1e. Challenges and open questions. Despite advances in understanding TRAPPIST-1e, many questions remain unanswered. Challenges include detailed characterization of its atmosphere, precise determination of its surface composition, investigation of possible geological and climatic phenomena, and assessment of risks from stellar events such as flares and eruptions that could impact the planet's habitability. Technological advances and future space missions. The development of advanced technologies is driving our ability to study exoplanets like TRAPPIST-1e. In addition to the JWST, future space missions such as the ESA's Plato Space Telescope and NASA's Roman Space Telescope are planned to expand our horizons in the search for life beyond our solar system. TRAPPIST-1e continues to captivate the imagination of the scientific community and the general public. Its potential to harbor liquid water and possibly life forms has spurred a wealth of studies and investigations. As we advance in observation and analysis technologies, we can expect exciting discoveries and profound insights into this distant world and its implications for life beyond Earth. 1E represents not only a fascinating exoplanet, but also a window into the wonders and mysteries of the vast cosmos that surrounds us.